Hello everybody. This video is on how to use Excel to make to calculate your statistics and make a graph. So when you use Excel, one thing you need to do is put your data into it. And there's lots of ways you can do this, but Excel works well if you make a little matrix like this, where for my example data that I'm going to make up, just so you know, I have the top of the hill, the side of the hill, and the bottom of the hill. And in each place, 3 samples were taken. So for this, my example data might be on water content, and so I'm going to make up some numbers here. So I'm going to say this is 13%, 15%, and 14%, and the side of the hill is 16, 17, and 15. I'm sorry, I'm coughing. And the bottom of the hill is 20, and 21, and 23% moisture. Okay, so this example data, you might be able to say, oh, if I just take the averages, that'll tell me that the top of the hill is drier than the side of the hill, which is drier than the bottom of the hill. But we can't be so sure about this, and we'll talk about statistics in class a little bit. But what we have to do is we have to conduct some statistical analysis. And for this type of data, where we have 3 different groups, we can do what's called an Anova, or an analysis of variance. Now this can be done in Excel. If you click on the Data tab, you should have a data analysis. If you don't have this data analysis, you can go to File, go to Options, and then, I'm going to bring this up to the screen, you can go to Add-ins, right here. Come on. Add-ins, and make sure that you have the Analysis Tool pack. And this is on my active application add-ins. If I didn't have it, it would be down here, and I would click on it, and I would click OK. Alright, so make sure that you have that add-in, and that will be helpful. Anyways, so I want to do data analysis, so I click here, and I said there's all sorts of things that I can do, but for what this kind of data is, we need to do an Anova single factor. The single factor is the place on the hill where we took the sample. So I'm looking at Anova single factor. 2-factor would be if I had the hill type and then there was another thing that was the same between all 3 places. I had grown some sort of crop and did a fertilizer analysis, something like that. So that would be a 2-factor, but this is a single factor. So click on single factor. My input range is where's my data. So that is my data, and since I'm clicking on, I'm going to say that labels are in my first row. And it is grouped by columns, because each column is how I have that. Now if you grouped your data in rows, you would click if data is grouped in rows. So I have alpha in this is set at 0.05, and we'll talk more about alpha in class, but just so you know now, this is the % chance of what I'm going to find being wrong. So this will make me 95% certain that these groups are actually different in reality versus what my samples say, and there's a 5% chance that maybe I'm sampling something that really isn't there. So 5% chance is really low, 95% chance is really good. We don't really want to go any greater than 0.05 because that would make my data more uncertain. Sometimes in soil science and ecology we can go up to 10% uncertainty, but mostly we'll just stick to 5%. That's sort of standard. Physics and things that go even lower than this, so certainly don't go any higher than 5% in this class unless I say that you can. And then it'll give me an output range. It can actually give me an output range that is on this sheet or I can it'll give me a new worksheet. So I'll let it give me a new worksheet today, and I will call it example output. And you'll see that it makes an example output for me. Okay, so it runs this, and then look, new data sheet down here, example output. Let's look here. It gives me my Anova single factor, and I have 3 groups, and in each group there were 3 samples. So it gives a sum of all the data, and an average of all the data, and then the variance. And that's the variance is how much each sort of the sum of the difference between each measurement to the mean. So and we see this big something comes up right here, and it's 19 when I thought that they were sort of all similar. So let's look and see if we have any significant difference between our 3 groups. And we're looking to see that the p-value is less than the alpha that we decided. And our alpha was 0.05, and we want our p-value to be less than 0.05. So our p-value is 0.25. So that means that we don't have a significant difference. And if I look at this variance on the bottom of the hill, the variance is much higher than the other ones, I might see what happened. So I'm looking at this saying, I don't have a significant difference. I thought I did. I go back over here and I realize, oh look, I meant to type 23, I typed 13. So make sure that your data is right. So let's change this to 23, what I was expecting my data to be input as, and I can redo the data analysis. Okay, have that. And there we go. Okay, so when I have my values to be right, see the variance got much smaller there, and then the p-value is less than my alpha. And so what that means is that if I go back to this original data, that the moisture content, or whatever data point I was measuring, variable I was measuring, at the top of the hill there's a difference somewhere between these 3 groups. Now this is a little bit tricky, is that the difference is somewhere between these 3 groups. It might be because the bottom of the hill is so much wetter than the others too, and it might be that these 2 are different. So in the next video you'll look at how you can make an LSB. But this is how to do an Anova. Thank you.